So the odds for this event, if the probability is 0.31, that means there's, out of, let's say the sample space is 100, there's 31 ways it's happening, and then the remaining 69 ways not happening, which is why the odds for would be 31 to 69. And then in part B, the sum is even or exactly divisible by 5. So the sum is even, meaning we're going to add the frequencies under 2, 4, 6, 8, 10, 12, and then divisible by 5, which is under 5, and 10 would be already added since it is even. So let's do that. 10 plus 50, 60, plus 110, that's 170, plus 170, that's 340, plus 120, that's 460, plus 70, that's 530, plus under 530 plus 70 would be 600. So it's 600 divided by 1000, which is 0.6. So the odds for would be 6 to, there's 6 ways happening, then 4 ways not happening. So it's 6 to 4, which is simplified 3 to 2. So in number 8, the formula is given, so just follow that. Probability C intersect D. So C and D intersect right here, 0.10. So 0.10 goes up here. And then probability D, so let's follow D across and find the total, which is 0.45. So it's 0.10 divided by 0.45. So 0.10 divided by 0.45, which is 0.22. That's number 8. Okay, let's look at this number 9. So we're drawing 2 cards from a standard deck. What is the probability that the first card is black and the second card is red? So in part A, we're drawing the cards without replacements. Okay, so and as you know, in a 52 card deck, half of them are black, half of them are red. So there's 26 red, 26 blue. So when you pull the first card, you have the first card, you want it to be black. So there are 26 black and 52 cards. So that's why the probability of pulling a black card would be just 26 over 52. So that's half. And then when you pull the second card, you want it to be red. So that's going to be again 26 over, because there are 26 red cards. But now there's not 52 cards, there's 51 left. Because you pulled a black card first, which means there were 25 black cards left. You still have 26 red. So that makes the total cards 51 instead of 52, because you're not replacing the cards without replacement. So this is the probability of pulling the second card red. And that's actually 26 over 51. And then the probability being asked is you just multiply these two. So this one times this one. So the answer is 0.2549. 0.2549. So part B is exactly the same, but this time we're replacing the cards. So when you replace, the first part will be again 26 over 52, and then so you pull the black card and then you put it back in, and now you pull again and you want it to be red this time. So it's still 26 because there are 26 cards. But now it's not 51, it's 52. So both of them are just half and half. So you multiply half times half, it's going to be 0.25. So 0.25. In our last question, 2 balls are drawn in succession out of a box containing 3 red, 2 white balls. Find the probability that at least 1 ball was red, given that the first ball was replaced before the second draw. Okay, so we're pulling 2 balls, and at least 1 ball is red, given that the first ball is replaced. So with replacement, at least 1 red. So that means it can be red, red, or we have red and white. Okay, red, white, or white, red. So since we're pulling 2 balls, both of them could be red. The first one could be red, or the second one could be red. And these are the situations where we have at least 1 red, correct? I don't need to count white, white, because that would be 0 red. And we need to make sure that we're replacing the first ball before we draw the second one. So now 3 red, 2 white balls. So let's write that down. 3 red and 2 white. So when I pull the first ball and I want it to be red, that would be 3 out of 5, right? So that's equals 3 out of 5. Okay, that's P red. And then the second ball, I want it to be red again, right? And I put the first one back, so again it's going to be 3 over 5, because there are 5 balls total and 3 of them are red. So then the probability of red, red, that would be, I just multiply these, equals those 2 multiplied. So that's 0.36 is the probability of pulling both balls red. And then in the second scenario, the first one is going to be red, which is actually exactly the same here, because it has to be 3 out of 5, so 3/5, 0.6. And now the second ball, I replace it, I want it to be white, so it's going to be 2 out of 5. I need to put equals in front of it. So 2 out of 5, which is 0.4. So probability red, white would be, just multiply these, and it's 0.24. And now the first one, the last scenario, the first one is going to be white, which is 2 out of 5, so it's again 0.4. The probabilities don't change because we replaced the ball. And red would be, since you replace it, it's going to be 3 out of 5. And the probability white, red would be again the same, because you multiply 0.4 and 0.6, 0.24. So then my probability of at least one red, would be this one plus that one plus that one, which is 0.84. And they want this as a fraction. So that's 84 over 100. If you simplify, it's 21 over 25. Okay, remove that. 21 over 25. We could actually just So that's 3/5 times 3/5, which is 9 over 25. So 9 over 25. No, that's not going to work. I give up. So you get the idea. 21 over 25. You can change this to a decimal, a fraction. 84 over 100. If you simplify by 4, you get 21 over 25. Let's look at part B, not replace before the second draw. Okay, so in part B, we still have the same three possibilities: red, 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 white, white, red. I'm pulling the first ball, the probability will always be the same. The second draw will be changed because you're not replacing the first ball. So these are going to be different then. So I'm going to change these. So you pull the second ball, you want it to be red, and the first ball was red, so that means there are 2 red balls left out of total 4. So that's going to be equals 2 over 4, which is half, and you multiply those, you get 0.3. And then in second scenario, you want the second ball to be white. The first ball was red, so you have 2 white balls out of 4 total. So it's going to be the same again, 2 over 4. And then probability red. The first ball was white, so that means there are 3 red balls out of total 4, because 1 white was drawn, now there's 1 white left, so 4 total left, so it's 3 over 4. And these multiplied, you get the same probabilities, and those are multiplied 0.3 times 0.3 times 0.3. Sorry, added, because these are separate cases, 0.9, which is going to be 9 out of 10. So that's 9 out of 10. Okay, you get the idea. It's 9 out of 10, 9 over 10. Alright, so that's all the questions for this week. Good luck on your quiz.